Let us now discuss TCP header. So this is the TCP header structure. The first row is of again 32 bits and which is having two parts. One is source port number which is of 16 bits, and destination port number which is also 16 bit. Then we have field sequence number, 32-bit field. Then we will have acknowledgement number which is also 32-bit. Then in the fourth row we have 16-bit of window size, and here we have first 4-bit for header length, then we have 6 bits reserved, then we will have some flags. One is URG flag, urgent flag, then we have acknowledgement flag, then we will have push bit, then we will have reset bit, next we will have synchronization bit, and we will have finish bit. Next in the row we have, so these are the 6 bits reserved. So you can see here also 4 plus 6, and there are 6 flags. So in total we have 16 and 16 again 32 bits. This is 32 bits. So every row is 32 bits. Here in the next row we have checksum, of 16 bits, and then urgent pointer, that is also 16 bits. And in the rest of body we have, this is the optional part, and which is 0 to 40 bytes. So again, just to remind you, the first 5 rows are of 32 bits each, or in other words 4 bytes each. But we have the optional field already in bytes given, which is 0 to 40. Again, it is a variable. Okay, 0 to 40 bytes ka hoga, and rest is your data. Okay, so this is what the structure of your TCP header. Now we are going to discuss one by one each and every field present here. So first we will see the source port number and destination port number. So source port number and destination port number each everyone each of which is having 16 bits. And with the 16 bit we have already discussed, that is we can have in total 2 raised to power 16 port number, whether it is source or whether it is destination port number. So in total we have 2 raised to power 16 port number, and that would be numbered from 0 to 2 raised to power 16 minus 1, which is 0 to 65535. Okay, so as we know that transport layer is end-to-end protocol, we know that by end to end means with process to process. So that is, let's say at any host we have some message, there are multiple processes running, these are nothing but the processes, this is the host, let's say this is the message. So in order to identify the process we need port number. So every process is running on a specific port number. Okay, that means, for example, let's say we have an application HTTP that would be running on port number 80, FTP is run on port number 21, telnet run on port number 23, SMTP run on port number 25, and so on. So there are few application for them, there are specific port number are already assigned. Okay, all the well-known services they run from 0 to 1023 port number. Okay, so these are the well-known services, and you will see the port number what they are given is that should be between 0 to 120, oh sorry, 0 to 1023. That is, in total we have 0 to 65535 port numbers. Okay, out of these port number we have 0 to 1023 port numbers that are given for well-known services. What are those well-known services? Like HTTP, FTP, Telnet, SMTP, etc. Okay, and from 1024 to 49151, these are the port number which are kept reserved. Okay, why these are kept reserved? Because whenever at later stage, whenever we have some application which becomes a well-known service, so what we can do, we can take port number from the reserved part. Okay, so that is why these port number are kept as reserved. Then next we have 49151 652265535. Okay, so these are the port number which are used for general purpose. Now we have already seen that whenever that every process run on a specific port number. Let's say this is port P, process P1, P2, P3, P4. So they might be running on a port. Let's say P1 is running on P1 is a HTTP process, and which is run on port number 80. Let's say P2 is some FTP process, so it will be running on port number 21. The rest process may be from 4 let's say 49902 or something, any random port number I have taken for this process. And similar for this process there would be some port number. Okay, so now the thing is, first of all, how would you are going to check the port number? So for that the command is netstat. So if you want to check the specific port number for a process, then you can use the command netstat. Now let us take an example and we'll see whether the whether only port number is you know sufficient to provide this end-to-end service or not. Okay, let us see. So let's say one example. Let's say this is one host and there are some process. Let's say it is running on some port number X, and there is another. Let's say this is the server, this is the client. Let's say it is a Google server. So at Google server there is a process running, let's say on port number 80. Now what is going to happen, अगर जब हमें ये प्रोवाइड कराना है कि ए एक मैसेज ए में ए मशीन पे या ए होस्ट नंबर ए पे ओके अगर कोई प्रोसेस है जो गूगल के सर्वर पे इस प्रोसेस को जो कि पोर्ट नंबर 80 पे रन कर रहा है इसको कोई मैसेज अगर सेंड करना चाहता है ओके so what we will do, we will send a message to the uh, to this host. Okay, let's say this is host B, or okay I name it Google or something. Okay, so क्या होगा यहाँ पे सोर्स पोर्ट नंबर X और डेस्टिनेशन पोर्ट नंबर 80 मेंशन कर देगा वो. Okay, now it seems fine कि whenever Google will see, or whenever the server of Google will see that a request came for port 80, so it is going to send the message to to message to the that this process. Okay, that seems perfectly fine. But as because this is a server और सर्वर में हम जानते हैं कि सर्वर एप्लीकेशन क्या है, मल्टीपल क्लाइंट्स को एक साथ एक्सेस या एक साथ रिप्लाई कर सकती है या एक साथ एक्सेस कर सकती है, एक साथ सर्विस प्रोवाइड करा सकता है. ओके, सो मान लीजिए इफ वी हैव ए सिचुएशन लाइक that we have another client, let's say the client number let's say we have name it C. Okay, and there is also one process and one random port number is being given X over here, because there is one thing to note here: in between a single machine or in between a single host there are if there are n number of process, so जितने भी n number of processes होंगे उनके पोर्ट नंबर आपके डिफरेंट होंगे. बट इफ यू टॉक अबाउट डिफरेंट मशीन और डिफरेंट होस्ट, सो डिफरेंट होस्ट पे आपके पास सेम आपका पोर्ट नंबर हो सकता है. ओके, सो पॉइंट नंबर 1 here to note is at same host ports number will be different for every process, but port number can be same for the processes running on different host. So this is something we can note. Secondly, we have already told you if client want to send a message to server, if the data is traveling from client to server, that means client का जो आपका पोर्ट नंबर होगा वो एक रैंडम पोर्ट नंबर होगा और डायनेमिक पोर्ट नंबर होगा, और जो सर्वर होगा उस पे जो प्रोसेस का पोर्ट नंबर होगा वो आपका एक फिक्स पोर्ट नंबर होगा. सो दैट इज व्हाई दिस पोर्ट नंबर इज गिवन एज डायनेमिक और रैंडम, and this port number is fixed. Now just by looking at this we can know we can get to know that the data is traveling from client to server. Now I'm coming back to the same question. So let's say होस्ट ए ने पे एक कोई प्रोसेस है जिसको एक रैंडम पोर्ट नंबर असाइन हुआ है, दैट इज एक्स. वो पोर्ट नंबर 80 गूगल के सर्वर पे पोर्ट नंबर 80 पे जो एक प्रोसेस रन कर रहा है उसको एक मैसेज भेजता है. ओके, So he will add source port number as X and destination port number as 80 and will send the packet to Google. Now, let us suppose the situation arises that another host having a process and it also gets the same random port number X, okay, and he also wants to send the data to the same process, and in this case he will also set the source port address as X and destination port address as 80. नाउ व्हेन द गूगल विल रिसीव गूगल के सर्वर पे जो आपका बफर होगा बफर में आपके पास ये दोनों पैकेट होंगे फर्स्ट पैकेट विच इज सेंट बाय ए अनदर पैकेट विच इज सेंट बाय सी तो यहाँ पे दोनों ही पोर्ट नंबर पे दोनों ही पैकेट में आपके पास एक्स और 80 की एंट्री होगी उस केस में how the Google will differentiate which packet to receive, that is how to differentiate which packet is coming from A, which packet is coming from C, and hence we have to use IP addresses along with the port number, okay, to uniquely identify or to make this to solve this problem. So उस केस में क्या है मान लीजिए let's say we have some IP address IA of this machine A, we have IC of machine C, and we have IB of machine B or Google server, okay. In that case, along with let's say if I do not take port number, okay, if I do not take port number as of now, if I only send the request like this by setting IA as IP address of the sender and IB as the IP address of receiver. Similarly here, if we send IC the IP address of this sender and IB as the रिसीवर का आईपी एड्रेस सो उस केस में केवल और केवल ये कहने से यहाँ तक तो पहुंच जाएगा लेकिन अगेन द क्वेश्चन इज कि किस प्रोसेस पे जाना है दैट विल that will be a question. So for that, in order to identify a connection uniquely, port number are not sufficient. First of all, ये हमें पता लग गया है. Okay, because two host chooses the same port number. So either you use only IP address or port number, then problem is not solved. IP address केवल IP address को भी यूज करेंगे तो भी हमारा प्रॉब्लम सॉल्व नहीं होगा क्योंकि केवल IP एड्रेस के केस में क्या होगा मान लीजिए मैं एक बार को ये मान लेता हूँ कि यहाँ से आपके पास एक और प्रोसेस है मान लीजिए A के पास एंड इट इज़ हैविंग द रैंडम पोर्ट नंबर Y मान लीजिए यहाँ पे है लेकिन अगर हम केवल और केवल आईपी एड्रेस ही सेंड कर रहे हैं सो जब ये प्रोसेस भी आपका डेटा सेंड करेगा टू द गूगल सर्वर ओके सो दिस इज आल्सो हैविंग द सेम पैकेट आई ए विद एंट्री आई ए एंड आई बी एंड दिस प्रोसेस इज आल्सो हैविंग द सेम एंट्री आई ए एंड आई बी सो फर्स्ट ऑफ ऑल इट इज़ क्लियर कि इस तरह से केस में केवल ना तो केवल हमारे पास आईपी एड्रेस पूरा सॉल्यूशन है और ना ही केवल हमारे पास पोर्ट एड्रेस पूरा सॉल्यूशन है एंड फॉर दैट वी हैव टू यूज बोथ आईपी एड्रेस एंड पोर्ट नंबर टुगेदर सो वी हैव टू यूज both IP addresses and port number in combination. And IP address और पोर्ट नंबर का कॉम्बिनेशन यहाँ पे 16 बिट का पोर्ट नंबर और 32 बिट का आपका IP एड्रेस ये कॉम्बिनेशन मिलके कहलाता है आपका सॉकेट ओके एंड दैट इज ऑफ 48 बिट्स which is having 32 bit of IP address and 16 bit of port number. Okay, so this is why socket is used for connection. Okay, so I hope it is clear. Now we will move to the next part of the TCP header, which is sequence number. So you can see sequence number is nothing but a 32-bit field. Before discussing the sequence number, there are few things to know. The number one thing is that TCP is a byte stream protocol. What do I mean by byte stream protocol? Is every byte is counted. Okay, so byte stream protocol, that is every byte is counted. That is whatever byte is appear from the application layer to transport layer, we put a number on it. Okay, that is what mean by byte is counted. So जो भी byte आपकी application layer से transport layer पे आ रही है उसको हम एक number assign करेंगे. Okay, जैसे TCP आपका एक byte stream protocol है, वैसे ही अगर हम बात करें network layer पे आपका जो IP protocol है, so at network layer IP protocol is a packet stream protocol. So packet stream protocol का मतलब same, every packet is counted. Every packet is counted. How we are going to count the every packet? That is, we are going to put the some number to every packet, and that number is nothing but your identification number. So जैसा कि पैकेट स्ट्रीम सॉरी आईपी प्रोटोकॉल में is a packet stream protocol, and to count every packet we have identification number. Similarly, TCP is a byte stream protocol, and to count every byte we have the sequence number. That means we will put a sequence number, unique sequence number to every byte. Okay, what is being received from the application layer. ऐसे ही अगर हम बात करें डेटा लिंक लेयर की, सो डेटा लिंक लेयर इज ए बिट स्ट्रीम प्रोटोकॉल. डेटा लिंक लेयर में अगर हम HDLC की बात करें जैसे, सो HDLC प्रोटोकॉल इज ए बिट स्ट्रीम प्रोटोकॉल. दैट इज एवरी बिट इज बीइंग काउंटेड. लैंग्वेज में बात करें तो जावा आपकी एक बाइट स्ट्रीम लैंग्वेज है. ओके, सो मूविंग अहेड, सीक्वेंस नंबर, पहली बात तो ये समझ में आया कि केवल सीक्वेंस नंबर सफिशिएंट नहीं है टू आइडेंटिफाई द प्रोसेस. वी हैव टू कंबाइन द सीक्वेंस नंबर, सॉरी, वी हैव टू कंबाइन द पोर्ट नंबर बेसिक विद द आईपी एड्रेस. तो सीक्वेंस नंबर किसके लिए है? सीक्वेंस नंबर आपका है basically to give a number to every byte. Okay, so that we can count, or you can say we can count the every byte in the TCP. Now at the TCP we called packet as segment. So ट्रांसपोर्ट लेयर पे हम लोग पैकेट इज ए जेनरिक नेम. ट्रांसपोर्ट लेयर पे हम इस पैकेट को ही क्या बोल देते हैं? हम सेगमेंट बोल देते हैं. नेटवर्क लेयर पे हम इसको क्या बोल देते हैं? पैकेट को डेटाग्राम. Now let's say we have one segment and we have one field that is sequence number. What would be this sequence number? This sequence number would nothing but the first byte, okay, in the data. सो सीक्वेंस नंबर इज नथिंग बट, जो इस आपके हेडर में जो सीक्वेंस नंबर फील्ड है वो क्या है आपका, जो आपकी डेटा बाइट्स हैं, यहाँ पे डेटा बाइट्स में जो पहली आपकी बाइट है, फर्स्ट बाइट है, उसका जो सीक्वेंस नंबर है वो आपका हेडर का सीक्वेंस नंबर होगा, हेडर में जो आपका सीक्वेंस नंबर होगा। ओके, सो द सीक्वेंस नंबर इन द हेडर इज नथिंग बट द सीक्वेंस नंबर of first byte. For example, let's say we have this segment in which this is the data part and this is TCP header. Let's say we have the first byte number, sequence number is 100, next is let's say 101, and so on. This is, let's say, last byte is, let's say, sequence number is having 150. So the sequence number that is we are going to put in the header is nothing but the sequence number of the first byte. Okay, so that means here the sequence number is going to be 100. Okay, there is another field in the third row is acknowledgement number or ACK number. So acknowledgement number is when we send a segment to other side, it will send the acknowledgement. Okay, and for that, to recognize that acknowledgement, we provide the acknowledgement number. Okay, so here the acknowledgement number is nothing but what is the sequence number of the byte expected next. Okay, so mind it, acknowledgement number is nothing but the sequence number of the byte expected next. What I'm trying to say, let's say we have this sender and we have receiver. Okay, so let's say the sequence number 100 वाला आपका जो बाइट है वो सेंड किया गया है. Okay, so when the receiver is going to send the ACK or acknowledgement. Okay, so acknowledgement में जो आपका acknowledgement number होगा, okay, that is going to be the next sequence number of the next byte. Okay, जो next byte का sequence number होगा वो होगा, that is something what the receiver is expecting. Okay, so it could be 101, so it would be something like this. So here, if we take the example, let's say this is the complete data segment, data in the segment. Okay, यहाँ पे आपके पास क्या है कि एक साथ कंप्लीट एक बार में सिंगल बाइट नहीं भेजी जाती है. सो यहाँ हो सकता है, मैंने अभी आपको यहाँ पे जो एग्जांपल दिया उसमें ये 100 है और आपको लग रहा है कि ये नेक्स्ट बाइट का आपका नंबर है. सो इट इज़ नॉट द नेक्स्ट बाइट नंबर, माइंड इट. It is something the number which is the segment byte which is expecting next. So here if I take the above example, so in the above example if you look at, so that means these whole data bytes are being sent in a single shot, and the next is up to 150 we have sent. Now the next receiver is going to expecting 151. So we have sent sequence number 100. So that means this segment is being sent. Okay, so this segment is sent. Let's say this is the segment with sequence number 100. And when the receiver is going to send the acknowledgement, it is going to set acknowledgement number as 151 because till 100 to 150 it has received. So up to 100, so from 100 to 150 bytes the receiver has already received. Now receiver is expecting the next byte to be 151. Okay, so the next byte जो सेंटर भेजेगा उसका सीक्वेंस नंबर क्या होना चाहिए, 151 होना चाहिए. So that is what we are trying to say. Okay, so acknowledgement number is nothing but the last, the sequence number of the byte expected next. Okay, so in this particular example, if you want to, if we try to calculate the acknowledgement number, so this 151 is nothing but the last byte sequence number plus 1. Okay, so the last byte which receiver has received is 150. Okay, and plus 1 will make it 151. So that would be the acknowledgement number. But here there is a question, that given the first byte sequence number, how receiver will going to calculate the last byte sequence number? Now what I'm trying to say here, that sender has sent a segment. Let's say I'm taking the above segment जो अभी हमने देखा ऊपर. Let's say the sequence number is equal to 100, is the same segment जो हमने पीछे लिया है अभी. So let's say sender ने ये send किया receiver को, that is sequence number of 100 is being sent. Receiver has successfully received this segment. Now he has sent the acknowledgement. Acknowledgement में जो आपका AC के नंबर होगा, वो AC के नंबर कितना होगा? 151, that we have seen. अभी ये 151 रिसीवर कैलकुलेट कैसे करेगा? बिकॉज जो उसको सेगमेंट मिला है, उस सेगमेंट में आपके पास जो डिटेल है वो आपके पास सीक्वेंस नंबर की है, फर्स्ट सीक्वेंस नंबर की है. सो जस्ट बाय हैविंग द फर्स्ट सीक्वेंस नंबर, हाउ द रिसीवर हैज कैलकुलेट द नेक्स्ट एक्सपेक्टेड सीक्वेंस नंबर? दैट इज अ क्वेश्चन. थिंक अबाउट इट. So in here I can say here in the TCP header there is a field header length. You can see in TCP header, this is the TCP header, there is a field header length. Okay, but there is no such field with total length. We have seen in IP header that there was a field of header length and total length both. But here in the TCP header, we only have header length, but we don't have any total length. So now how the receiver is going to calculate the how much data byte he has received, and how he is going to calculate the last byte sequence number, and by adding plus 1 he will going to set the ACK number. So that is a question. So the answer is it will be calculated using IP header only. As IP header have total length, okay, here you can see that every TCP header, every TCP segment travel in IP datagram. So just look at here. So let's say we have, this is something the transport layer and this is your network layer. So in the transport layer we have transport header, sorry, TCP header. Okay, we have TCP header and we have data, that is this is 100. TCP 100 में जो आप TCP header में जो आपका सीक्वेंस नंबर है वो भी 100 रहेगा, and that is let's say 150. Okay, this is what the segment size is. यहाँ पे हमारे पास है. ये जाएगा आपके पास नेटवर्क लेयर को. नेटवर्क लेयर क्या करेगा, अपना एक साथ में खुद का हेडर ऐड कर देगा, that is header of network layer. And in the header of network layer we have one field called header length, and another field we have total length or length of the packet. Okay, and rest is just the payload what he has received from the transport layer, and that is what, that is transport layer header, sorry, the TCP header and data. Okay, the above one. Now just because the network layer header or IP header have header length, okay, so by multiplying it by 4 it will calculate the size of network header. Let's suppose it is coming out to be 20 bytes. Okay, जैसा हम पहले देखते आ रहे थे, minimum header length, and it will also have the total length, and that total length is nothing but this is what the total length is. And you can see that we can calculate the payload from from payload from transport layer can be calculated by total length minus header length. Okay, this is IP header. Okay, IP header length. So now this is how we will calculate this portion. Okay, now we have one field called as header length in TCP header also. So this header length will give me the length of header of TCP header. Okay, so TCP header की length मुझे मिल जाएगी. And once I got this, what I am remaining with the data. And by looking at the first sequence number, if I have the length of data or length of this message, so we can calculate the sequence number of the last byte, and by adding +1 we can calculate the ACK number. Okay, so for example, let's say I take the header length. यहाँ पे TCP header length की भी अगर हम बात करें, so you can see in the diagram or structure of TCP header, this is nothing but the 20 bytes that is fixed. इतना तो TCP में होगा ही, and this is the optional part. So minimum header length अगर हम बात करें in case of TCP header, that would be of 20 bytes, and maximum it can be 60 bytes. So that is same as IP header. IP header भी आपका minimum 20 byte का था और maximum 60 byte का था. Similarly TCP header भी आपका 20 byte का minimum है और 60 byte maximum है. So if I take the minimum of it, and let's suppose the TCP header is also coming out to be 20 bytes, and I assume that net IP header जो है वो आपका IP header भी आपका minimum है, that is 20 bytes. So and let's suppose total length is, let's say 1000 byte. Okay, so how we have calculated this IP header, because there is a field header length, and if we multiply it by 4, okay, so that will give me this. So definitely वहाँ पे header length की value 5 रही होगी. If I multiply by 4, so I will get 20. So that is how I received the IP header size. IP header size मिल गया मुझे, total length मुझे पता है. Okay, so I can calculate payload from transport layer, and that is coming out to be 1000 minus 20, and that is 980. And out of 980 I have already calculated this TCP header size. Okay, and TCP header size में भी आपका इसी तरीके से है. यहाँ पे आप देखें अगर this header length is again 4-bit field. Okay, 4-bit field है ये. यहाँ पे 4-bit field, again it can, with the 4-bit we can have 0 to 15 number of values. Okay, that is we can store, if I want to make 20, so the value could be 5. So that there should be scaling factor, and that scaling factor again we can calculate in the same manner, that is 60 by 15, it is equal to 4. Okay, so if I make value, if I put value in the header length 15 and I multiply it by 4, that will give me 60. That is the total header size. Okay, similarly if I have the value 5 in this header length, and if I multiply it by 4, I will have 20, and that is the minimum header size. So this header length will can have value between 0 to 15, but in actual it will have a range 5 to 15, that is minimum 20 and maximum 60 if I multiply it by the scaling factor, which is 4. Okay, so in the same manner it works in the same manner, that we have done in the IP header part. Okay, now coming out to the example. So this was the example. So let's say आपका यहाँ IP header में भी header length जो है आपके पास जो given है वो आपके पास let's say 5 है. If you multiply it by 4, and you will get the header size 20 bytes. Out of this payload, if I subtract 980 minus 20, then I will get 960, and this is what the data is. That means if this size of data is 960 bytes, and the first byte sequence number is 100, then what would be the last byte sequence number? So that would be 960 plus 100 minus 1. That would be the last byte sequence number, and that is coming out to be 1059. Okay, that is the last byte sequence number I got 1059. Okay, so in this case, the last byte sequence number is 1059, and hence the acknowledgement number we can calculate by adding plus 1. Okay, so acknowledgement number can be 1059 plus 1, that is 1060. So that would be the acknowledgement number given in this given example. Okay, so this is how the acknowledgement number is going to be calculated. Now we will see again, we will come to the sequence number part, and we'll see there are three phases in TCP connection, and in the TCP protocol basically it follows, it is a connection oriented protocol, so it follows, first step is connection establishment, then second step is data transfer, and third step is connection termination. Okay, so we will see first, before going to that, let me show you, what could be the sequence number of the sender. So let's say we have this is the sender and this is the receiver. Let's say the random port number I have taken is X, and IP address of this sender is IS, and here let's say the port number, fixed port number is 80, and IP address of this receiver is IR. Let us suppose sender want to send the data bytes, and which is, this is something the header, TCP header. Let's say we have these number of data bytes in the segment. This is the whole segment. The, let's say, first sequence number, what if I kept this as 0, and let's say this is 99. Okay, so in total we have 100 bytes of data, and let's say I name the first sequence number as 0, and the last byte sequence number is 99. Though this 99 is not being calculated at the sender end, it is going to calculated at the receiver end, जो मेथड हमने अभी पहले डिस्कस किया है उस तरीके से. By that method, receiver is going to calculate the last byte number, and by adding plus 1 he will get the next byte expected number or acknowledgement number. Okay, so let us suppose just by for simplicity में भी आपको दिखाने के लिए यहाँ पे इसको लेके चल रहा हूँ. So let's say we have a range of 0 to 99 bytes over here. क्या हम सीक्वेंस नंबर 0 रख सकते हैं? दैट इज व्हाट आई एम ट्राइंग टू से, कि सीक्वेंस नंबर हमारा हो तो क्या हो. सो यहाँ पे जब मान लीजिए एक बार हम सीक्वेंस नंबर 0 रखते हैं, तो मैंने यहाँ पे सीक्वेंस नंबर हेडर में क्या आ जाएगा, सीक्वेंस नंबर 0 आ जाएगा. सो व्हेन वी आर गोइंग टू सेंड दिस सीक्वेंस नंबर 0, so it will have the data range from 0 to 99 and having the sequence number equal to 0. Now let us say there are further bytes which are 100 to further segments which are 100 to, let's say, 199. Okay, and it is also being sent to the receiver. The sequence number of this segment or this segment header would be 100. Let us suppose it gets lost. Okay, इसके बाद फर्दर सीक्वेंस नंबर सेंड किए गए. ठीक है, लेट्स से एक और सेगमेंट सेंड किया गया जिसमें सीक्वेंस नंबर आपका फर्स्ट बाइट का सीक्वेंस नंबर 200 है, so that is why sequence number in the header is 200. Then another, let's say it is 300, and so on. Now let us say, what if this is not being received, okay, by the receiver. So this segment is not being received by the receiver, and by then the connection is lost, or you can say connection is terminated. Okay, so here the connection is closed. Later on, assume that just after some time, assume that it is having the same IP address, वापस से वो उसको कोई डेटा भेजना है, और let's say if he again start sending the data, and if we again start the sequence number from 0, previous connection was closed. So now what actually happens next time, let's suppose this got delayed. ओके, ये वाला आपको रिसीव नहीं हुआ था, इसका ये मतलब नहीं है कि ये लॉस्ट ही हो गया था, इसका मतलब ये भी हो सकता है कि इट गॉट डिलेड बिकॉज एवरी सेगमेंट इज कमिंग फ्रॉम द डिफरेंट डिफरेंट पाथ. सो इट मे बी पॉसिबल कि वहाँ पे आपके पास डिले ज़्यादा हो, वो किसी ऐसे नेटवर्क में हो, और वो अब जाके रिसीवर को यहाँ पे मिलता है. जब रिसीवर को वो अब जाके मिलेगा, और यहाँ पे भी आपके पास नेक्स्ट सेगमेंट आपका कुछ इस तरीके से है कि जिसका आपका सेगमेंट जो है, व्हाट रिसीवर इज एक्सपेक्टिंग 100. ओके, इन दैट केस क्या होगा, रिसीवर विल एक्सेप्ट दिस segment also by assuming that this segment is in actual this segment. Okay, so receiver उसको accept कर लेगा, and that is not wise because when they are going to compile, reassemble that segments or compile the data, उस केस में they will got some error. So this is something that should not be done. So that means we cannot always start, whenever we start a connection, whenever a connection is being established, we cannot start the data transfer by making a sequence number as zeros. ओके, सो ऐसा नहीं है कि हमेशा जब भी एक अब हमें स्टार्ट करना है, कोई डेटा ट्रांसफर स्टार्ट करना है, सो सीक्वेंस नंबर हमेशा हमारा स्टार्ट जीरो से हो. सो वी हैव सीन दैट द प्रॉब्लम. सो वी कैन से we don't always start with sequence number 0 because the problem was that the packet from previously closed connection is going to be accepted as the present connection. Now what is the solution for that? Now we can start with a random sequence number. Okay, so now ये हमने देख लिया कि every time we cannot start with a sequence number 0, and the solution for that is we can start with a random sequence number. Now with the random sequence number, what is happening, what is going to happen, let's say this is sender and receiver, and initially sender has sent the data with sequence number, let's say a random sequence number was 500, then it has sent next 600, next 700, and then the termination, oh sorry, the connection is terminated or the connection is closed. So let us suppose in the same situation, if the sender is having the same IP and again want to send the data, so it will establish the connection and start sending the data again. Now this time it will again choose a random sequence number, but this time the random sequence number would be different from the previous one. Okay, so let us say it would have sequence number like this, and so on. Okay, so even if any this packet is being delayed, okay, and it is reaches now, okay, so now the receiver will get to know that 600 is not the sequence number that I am expecting, and that is not even in the range of the sequence number I am receiving or I am expecting. Okay, so it will simply going to discard it. So it will discard the packet. Now you may question that it is a random sequence number. Random sequence number में ऐसा हो सकता है कि पहली बार भी random sequence number यही जनरेट हुआ हो और सेकंड टाइम भी हमने जो random sequence number जनरेट करना चाहा तो तभी भी आपका सेम random sequence number जनरेट हुआ हो. So if you look at that, it is possible, but it is very very rare. Okay, so the probability of getting the same number, same random number is very less. Okay, you can see because sequence number is a 32-bit field. That means in total we can have 2 raised to power 32 sequence numbers. Okay, and out of this 2 raised to power 32 sequence number, probability of getting the same sequence number, that would be 1 divided by 2 raised to power 32. And you may calculate, this would be something 1 divided by, this would be approximate to, 2 raised to power 30 is GB and 2 GB around. Okay, so if you calculate, anyway, 2 raised to power 2, that is 4, and into 2 raised to power 30, and this is nothing but 1 GB. Okay, so that is nothing but 10 raised to power 9, 1 upon 4 into 10 raised to power 9. So you can see, this will be coming out to be 0.0000000. Okay, so anyway, and in the last we have 25. Okay, so many zeros, and after that we have 25. So you can see, this is what the probability of getting the same random number, same sequence number. Okay, if we choose the sequence number randomly. Okay, now again there is a question, and the question is कि ये तो जरूरी नहीं है कि स्टार्टिंग में आपका 500 वाला हो. ओके, लेट मी टेक वन एग्जांपल एंड देन आई विल मेक यू अंडरस्टैंड. So let us say we have situation like this. So initially when the connection was established and data transfer with a random sequence number, let's say 500, and then the sequence number is coming out to be 600, and then let's say sequence number 700, connection is closed. Okay, then further connection is being established and a random sequence number is being chosen. So getting a random sequence number 500 is, we have seen, that is 1 upon 2 raised to power 32. Okay, which is having a very less probability, but we can have a sequence number 700 now, and that is from this window. And probably when we receive this, it may be chance कि ये वाला delay हो और ये यहाँ पे पहुँच जाए. Okay, so we are not though getting the same sequence number. Okay, but we can have a range of sequence number over here. So even though the probability of having the range of the sequence number is also very low. For example, you can say, let's say 500 से 1 million इधर रखते हैं और 1 million इधर रखते हैं. Okay, so let's say this is the range. So let us see the probability of getting the sequence number within this range. Okay, what would be the probability? And that probability is 1 million, and 1 million in total we have 2 million. So 2 million out divided by 2 raised to power 32. That would be the probability. And that is again 2 into 10 raised to power 6, and we have then this is 2 raised to power 32. Again it is going to be very less. Okay, again it is going to be 0.00 and so on. So again, if we try to calculate that getting a sequence number within the range, within the range of 2 million, we will have very less probability of having the same the sequence number within the range. So we can use the random sequence number one. So whenever a TCP connection is established, so we will always start with a random sequence number. Rather, we will start with a sequence number equal to 0. So we are not going to always start with a sequence number 0. Yes, sequence number 0 can happen. Okay, but if it is chosen as randomly, because then next time we are again choosing the sequence number randomly, and that will not going to be 0 or the range nearby 0, उसके पास आपके पास वो नहीं मिलने वाला है. Okay, so that is why we always choose the sequence number randomly. So we can say TCP uses random initial sequence number. We call it RISN. So this thing for sure that we use random initial sequence number in TCP, and that resolve the problem कि अगर कोई भी पुराना प्रीवियस कनेक्शन का पैकेट अगर आपको रिसीव होता है रिसीवर को, सो वो उसको रिकॉग्नाइज कर लेगा और उसको डिस्कार्ड कर देगा. सो दैट इज द प्रॉब्लम विच इज बीइंग रिजॉल्व फॉर द सीक्वेंस नंबर. बट वी हैव अनदर प्रॉब्लम विद द सीक्वेंस नंबर, एंड दैट इज रैप अराउंड. So let us see what is wraparound and what is wraparound time. So the thing is, we know that 1 KB is nothing but 2 raised to power 10 bytes. 1 MB would be 2 raised to power 20 bytes. 1 GB would be 2 raised to power 30 bytes. So as because we have 2 raised to power 32 sequence number, unique sequence number, or in other word we can say that we have 4 GB sequence number. Okay, so we have 4 GB sequence number, that is if every byte going out of TCP is having a sequence number, then how many bytes can I uniquely number and send them? So using 4G sequence number, I can send 4 GB data. Using 4 GB sequence number, I can send 4 GB data, because every byte is given a sequence number. Okay, and if we in total if we have 4 GB sequence number, that means I can send 4 GB of data using these 4 GB sequence number. Okay, and this is the maximum I have. But what if application layer send more than 4 GB data? For example, if you are downloading a movie or something, and that is more than 4 GB in size, so what is going to happen? उस केस में आपके पास सीक्वेंस नंबर कहाँ से आएंगे? We in total we have 2 raised to power 32 यूनिक सीक्वेंस नंबर, और 4 GB डेटा तक का ही हम डेटा सेंड कर सकते हैं, ये हम देख चुके हैं. So what if the application layer send more than 4 GB? So in that case, we have to wrap around the same sequence number. That is, we have sequence number ranging from 0 to 2 raised to power 32 minus 1. So once all of these sequence number are finished, we have to again reuse the same sequence number. So this is something if we have started from 0, but what if we have started from a random sequence number? So let's say this is the random sequence number. So once we have received the random sequence number, it is going to be something like this. We have to wrap around. Okay, and once we have reached to all the 4 GB sequence numbers, we have to reuse the same sequence number again and again. Okay, दैट इज द केस. सो इसके 4 GB के बाद अगर जो यूज होगा वो मुझे सेम सीक्वेंस नंबर यूज करना होगा. ओके, सो व्हाट इज द रैप अराउंड? Wrap around is using of all the sequence number that are present and reusing the same sequence number that has already been used. Okay, that is what the wrap around. So wrap around is using of all the sequence number that are present and reusing the same sequence number that has already been used. So this is what the wraparound. Now there is one more terminology, that is wraparound time. So wraparound time is nothing but the time taken to wrap around. So wraparound time is nothing but time taken to wrap around. That is after how much time you have to use the same sequence number. That is after how much time you have to use the same sequence number. Okay. Now wraparound time depends on bandwidth. How? We will see. So first of all, wraparound time depends on bandwidth. That is the rate at which data bytes are going out, the rate at which we are going to consume the sequence number. For example, we have sender and we are sending the sequence number, let's say from any random sequence number, or let us say as of now I just for simplicity I start with 0 and up to I have sent 2 raised to power 32 minus 1. So जिस तेजी से ये जाएंगे उतने ही तेजी से आपके पास ये सीक्वेंस नंबर खत्म होंगे, और कितनी तेजी से जाएंगे ये वो डिपेंड करता है मेरी बैंडविड्थ क्या है. ओके. सो जितनी ज्यादा बैंडविड्थ होगी उतना ही कम मेरा रैप अराउंड टाइम होगा. सो आई कैन से रैप अराउंड टाइम इज इनवर्सली प्रोपोर्शनल टू बैंडविड्थ. जितनी ज्यादा बैंडविड्थ होगी उतना ही कम मेरा रैप अराउंड टाइम होने वाला है, उतना ही फास्ट मैं कंज्यूम करूंगा इन डेटा बाइट्स को. ओके. सो फॉर एग्जांपल लेट्स से इसको एक एग्जांपल समझते हैं. लेट्स से बैंडविड्थ इज 1 Mbps. इसका मतलब क्या है कि 1 सेकेंड में मैं कितना डेटा ट्रांसमिट कर सकता हूं 1 MB. दैट इज 10 raised to power 6 bytes can be sent in 1 second, and or in other word I can say 10 raised to power 6 sequence number, because every byte is having a sequence number. So I can say 10 raised to power 6 sequence number can be sent in 1 second, and that is how 2 raised to power 32, or you can say I would write it 4 GB sequence number can be sent in 1 by 10 raised to power 6 into 4 GB. Okay, and that is 4 into 10 raised to power 9 divided by 10 raised to power 6, and that would be around 4000. That would be approximate to 4000 bytes or 4000 seconds. Okay. So this is the simple calculation. If you make the calculation in 2 raised to power, that would be something different, because that would be come out to be around 4294 something. Okay. So in actual that would be coming out to be this much. So now you can see that to consume all the 2 raised to power 32 bit sequence number, okay, we need this much of seconds. कि इतने सेकंड में 4000 सेकंड में अप्रोक्सीमेट 4000 सेकंड्स में we will consume all the 2 raised to power 32 sequence number. And in today's network we have lifetime of your packet is 180 second. That is, for 180 second a packet is going to be live, and after that it is going to be discarded. Okay. So here no problem is that if we have bandwidth of 1 Mbps, because हमारे पास दोबारा अगर कभी यूज करना होगा तो 4000 सेकंड के बाद यूज करना होगा हमें दोबारा से सीक्वेंस नंबर, क्योंकि 4000 सेकंड तो लगेंगे 2 raised to power 32 सीक्वेंस नंबर को कंज्यूम करने में, और किसी भी एक पुराने सीक्वेंस नंबर की लाइफ टाइम जो है वो 180 सेकंड होने वाली है. सो वन उससे पहले ही हमारे पास वो पैकेट डिस्कार्ड हो चुके होंगे पुराने वाले, दैट मीन्स वो नेटवर्क में अभी लाइव नहीं होंगे. So there is no problem when we have wraparound time if wraparound time is greater than lifetime. Okay, then everything is perfect. We have no issue. But now let us assume we have the bandwidth, and that is 1 Gbps. And if we have the bandwidth 1 Gbps, that is in 1 second, how much data can be sent? 1 GB data can be sent. That is, I can say 10 raised to power 9 bytes of data can be sent in 1 second, or uh, and hence 2 raised to power 32, or you can say 10 raised to power 9 sequence number can be sent in 1 second. That is 2 raised to power 32 sequence number. How much time will it take? 1 upon 10 raised to power 9 into 2 raised to power 32. So that is coming out to be 4 second, or 4 point, to be accurate, 4.294 second. Okay. Now we can see कि 4 सेकंड के अंदर अंदर मेरे पास सारा डेटा कंज्यूम हो जाएगा, और ये सारे 2 रेस्ट पावर 32 बिट 2 रेस्ट पावर 32 सीक्वेंस नंबर कंज्यूम हो जाएंगे. एंड वी हैव लाइफ टाइम इन टुडेज नेटवर्क इज 180 सेकेंड्स, एंड 180 सेकेंड तक पुराने सीक्वेंस नंबर भी आपके लाइव होंगे, और वी हैव टू रीयूज द सीक्वेंस सेम सीक्वेंस नंबर, then there might be a problem. Okay, so when we will get a problem, when we have wraparound time less than lifetime. Okay, in that situation we will have some problem. अभी इस प्रॉब्लम को कैसे रिजॉल्व किया जाए? इस प्रॉब्लम को रिजॉल्व करने के लिए आप बोलेंगे ओके बैंडविड्थ को आप कम कर दीजिए, द प्रॉब्लम इज गोइंग टू रिजॉल्व. बट बैंडविड्थ कम करना आज की तारीख में इज नॉट ए सॉल्यूशन, बिकॉज एवरी वन वॉन्ट बैंडविड्थ, मोर बैंडविड्थ. जितना ज़्यादा बैंडविड्थ आप दो उतना ही कम पड़ता है लोगों को. सो बैंडविड्थ को कम करना इज नॉट ए सॉल्यूशन हेयर. नाउ व्हाट इज द अदर सॉल्यूशन? अदर सॉल्यूशन इज कि आप सीक्वेंस नंबर को आप बढ़ा दीजिए. ठीक है, टोटल नंबर ऑफ सीक्वेंस नंबर जो है हमारे पास 2 रेज़ टू पावर 32 है. व्हाट आई कैन डू नाउ, आई कैन इंक्रीज सीक्वेंस नंबर. अच्छा, अब कितना इंक्रीज किया जाए? सो पहले देख लेते हैं कि लाइफ टाइम में हमें कितने सीक्वेंस नंबर कंज्यूम होते हैं. ओके, उस हिसाब से हम उसको कैलकुलेट करते हैं. सो we can calculate, let us say in the same example, let's say we assume bandwidth is equal to 1 Gbps. Okay, this is byte. Okay, so 1 Gbps is the bandwidth, and lifetime is equal to 180 second, and I don't want any wrap around to occur within the lifetime. Okay, मैं इस लाइफ टाइम में कोई रैप अराउंड नहीं होने देना चाहता. सो रैप अराउंड टाइम शुड एटलीस्ट बी 180. इसका मतलब मुझे कम से कम रैप अराउंड टाइम कितना रखना पड़ेगा? 180 रखना पड़ेगा. ओके, सो हेयर इफ आई सॉल्व दिस इन द 1 second, we can consume 1 GB of data, or I can say in 1 second I can consume 1G sequence number. Okay, so in 180 seconds how much sequence number are going to consume? That is 180 into 1G sequence number. Okay, so these much sequence number should be available to me. इतने मेरे पास अगर सीक्वेंस नंबर अवेलेबल हैं, देन आई डोंट हैव एनी प्रॉब्लम, क्योंकि उस केस में मेरे पास रैप अराउंड टाइम कितना होगा? 180 सेकंड होगा, और रैप अराउंड टाइम 180 सेकंड है, लाइफ टाइम भी 180 सेकंड है. ठीक है, दैट मीन्स कि 180 सेकंड में पुराने वाले तो सब लाइव रहेंगे नहीं, और मैं दोबारा से रीयूज कर सकता हूँ. ओके, सो हेयर if we try to calculate the minimum sequence number required to avoid wraparound within the within the lifetime is, so what I'm trying to say is minimum sequence number required to to avoid wraparound, within the lifetime, and that is equal to 180 into 1G sequence number. ओके, सो इतने सीक्वेंस नंबर के लिए कितनी बिट्स की रिक्वायरमेंट होगी? यू कैन कैलकुलेट बाय टेकिंग द लॉग ऑफ इट. सो लॉग बेस 2 and 180 into 1G. Okay, and that would be log base 2 180 into 10 raised to power 9, and that is coming out to be 42 bits. Okay, so that would be 42 bits. That means if I reserve 42 bits for the sequence number, okay, in the header, then there would be no problem. But you can see uh, in the TCP header, we have, for the sequence number, we have only 32 bits and we are required 42 bits. So what are these, ये बाकी की extra 10 bits कहाँ से ली जाएंगी? ये जो एक्स्ट्रा 10 बिट्स हैं, 42 minus 32 is equal to 10, and these 10 extra bits are taken from the option part. ओके, सो जो आपके पास ऑप्शनल फील्ड है टीसीपी हेडर में, वहां पे से आपकी ये 10 बिट ली जाएंगी, एंड दैट आर गोइंग टू यूज फॉर extending your sequence number, okay, up to this limit. Okay, similarly, if the bandwidth is going to increase, okay, from 1 gbps to 10 gbps, similarly we need some more extra more extra sequence number and more extra bytes to store the sequence number. So this is how we can calculate, okay, depending on the bandwidth. सो वी कैन कैलकुलेट कि कितनी बाइट आपकी रिक्वायर्ड होगी. जो एक्स्ट्रा बाइट है वो आपकी किस में से ले ली जाएंगी? ऑप्शनल फील्ड में से ली जाएंगी. एंड ऑप्शनल फील्ड इट हैज 0 to 40 बाइट्स. ओके, सो दिस इज क्लियर. सो द general formula for this to calculate the sequence bit required, nothing but log base 2 lifetime into bandwidth. Okay, so that is the number of sequence bit.